Okay, so we got a lot of enhancements. Three-axis milling, obviously, because three-axis is the most used toolpath methods that we have. And initially, what we've got here is we've added toolpath optimization. Toolpath optimization tab up here, and if you look down, you have feed rate reduction factors, feed rate reduction parameters. Now, these feed rate optimization parameters, we did have them in the product, but it was only after the fact. In other words, you had to go into the toolpath editor and apply feed rate optimization to a toolpath after you have generated it. And then if you generate it again, then you would have to go back and add them again. So we've modified this and moved the feed rate optimization up into each of the toolpath operation dialogues that supports it. So basically all 2-axis, if you have any linear toolpaths in 2-axis, you can apply feed rate optimization. Also in 3-axis, all of the linear 3-axis, any of the 3-axis that cuts in levels, you have basically, you look on the left here, we got one level here. This is facing, obviously, but any 3-axis that also is similar, where you're cutting in levels and you have a toolpath on a flat plane that's wrapping around corners, you can apply the toolpath optimization parameters. So if you look at these dialogues, let's take a moment to look at these pictures we've got here. So on the left, we've got the toolpath optimization, feed rate reduction parameters. Okay, so currently, if you look at these two parameters right here, where you see, let's see. Hold on a second. Okay. Look at my feed rate.
The most important parameter is the corner angle.
Yeah.
So depending on your corners, so the idea here is when you hit a corner, if your machine wants to slow down the feed rate, then this is where you will set the corner angle. So if you have a 90-degree angle, anything steeper than 90 degrees in those corners, if you want to actually slow down the feed rate, you'll specify that angle, corner angle here, set to 90 in this dialog. And then, of course, the distance where you want to start the feed rate reduction. Where do you want it to start? So if it's a linear motion coming into the corner, we break up that linear motion based on that distance you specify, and then apply that feed rate. So again, after the corner has been cut, when do you want to reset the feed rate back to the normal feed rate? That's the next parameter. So yeah, these are the controls we have. And then obviously the feed rate reduction percentage. How much do you want to reduce the feed rate as you're going into the corner, and then ignoring certain types of motions also. So quite a bit of control, and we see this as an area that we're going to be constantly working on to improve feed rates and other sorts of optimizations for the toolpath in the coming releases.
Okay, thanks, Joe. What I was getting at is the feed rate reduction percentage. You see this is set at 0.25. So if you look at the G code here on the right, we see with no feed rate optimization. So the cut feed rate was set to 10 in the actual the cut parameters tab, or in the feeds and speeds tab, excuse me. And then the G code in the middle is with the feed rate optimization applied. You see you have your initial feed rate of 10, and then when it approaches each corner, it drops down to 2.5 or 25%. So that'll do that through the entire toolpath and make those adjustments. And I did want to mention also, one of the main reasons to use this is to alleviate some of the stress on your CNC machine. Okay, so let's talk about our 3-axis enhancements for version 2025. The one I'm going to show you here is we now have feed rate optimization available in all leveling toolpaths. By leveling, I mean not just two axis facing, pocketing, profiling, etc., but also in horizontal roughing, where you have flat level cut levels, and any other operation type that creates a flat planar area. Okay, so in this particular part, we have a couple of parts and they sit on top of a plane, okay, that we're going to use to machine them. So let's look at what we have here. We have horizontal roughing. Let's take a look at that. Okay, we got no control geometry selected, so it's just calculating what it can remove. We got a flat mill, quarter-inch flat mill, cutter parameters. These are all straightforward. You'll be familiar with all of these. Let's go ahead and look at the cut levels. So here, pretty much standard. We have an extra button here called Add Stock. I'm going to go over that in another part in just a moment. And then also engage and retract. We're using a helical engagement. We're doing some arc fitting. Toolpath optimization. So here, if you're familiar with our feed rate optimization in version 2024 and prior, you may know that feed rate optimization was an edit that we did after the fact. So you could only do it in a toolpath. Let's save this. I'll show you. You could only do it in the toolpath editor, okay? And if we go to the global edits, okay, and you'll see that we have a number of commands up here, and one of them is feed rate optimization. You'll see that all of the same parameters now are in this tab called toolpath optimization, the section called feed rate reduction parameters. So these are the same parameters. The difference is, the major difference, however, is that prior to 2025, feed rate optimization was an optimization that you applied to an existing toolpath that was already generated. Okay, so you go through your CAM phase, you have all of your operations generated the way you want them, and then you would go in after the fact, edit each toolpath to apply feed rate optimization, which obviously you probably figured out what the downside of that is, that if you make a change to the toolpath and regenerate it, the feed rate optimization parameters are lost. So you got to reapply them again. So the enhancement in 2025 is that we moved the feed rate optimization or the feed rate reduction parameters into the toolpath dialog so that they are applied when the toolpath is generated. So there's no other side steps that you have to do to get toolpath optimization implemented. So let's see what we've got for toolpath optimization for the horizontal roughing. The main thing to look at is the feed rate reduction percentage. So we want to reduce the feed rate 50% or 0.5 when it reaches a corner of less than or equal to 90 degrees. So anytime it comes to a corner that's less than or equal to 90 degrees, the feed rate's going to drop by 50%, okay? And then it's going to pick up at 100%, and these are the distances. Say an eighth of an inch before a corner, it's going to drop 50%. An eighth of an inch after the corner, it's going to go back to 100%, okay? So let's go ahead and regenerate this, okay? And let's go ahead and look at what the feed rates are. So we have a cut feed rate of 4 inches per minute. Now, in version 2024, that would be the cut feed rate throughout the whole path. It would not change. Come to a corner, your router will have to come to a complete stop and then start and stop, start and stop, and you actually can see that jerking motion on your router if you have a lot of angles sharp angles in your toolpath. Now we have other things you can do, such as some looping and stuff like that, which helps also. But now you can actually control the feed rates at those corners. So toolpath optimization, it's enabled, okay? And the feed rate is set to 4 inches per minute. Okay, so let's generate that. Okay, let's see what our post is set to. Our post is set to Haas cut com. I think that which should be all right. Let's go ahead and pick OK there, and let's post this and see what we got. Okay, so let's look at this. So our feed rate optimization was enabled. The feed rate was 4 inches per minute. Okay, so at the corners, we have a lot of corners. So at the corners, it should drop by 50%. So what you're seeing here is we got a feed rate of 4. It's dropping to 2, 50%. All the way through here, it's dropping 50% at corners. Anytime where you see an F2 is where it's dropped from an F4 to an F2. So this is feed rate optimization in action, and how it looks in your G code itself. If you don't see the reduced feed rate in your posted G code, you need to make sure that you have it enabled in the operation dialog, which is called toolpath optimization. Make sure that is enabled, and make sure you have the parameters set the way you want them to be set. Okay, let's cancel out of that. Let's see what else we have up here. So that was horizontal roughing. It also will not apply to horizontal finishing that's not planar. So we have a contoured parallel finishing. It will not apply to that situation. But if we go on down to the facing, this is a planar toolpath with a lot of sharp corners that will apply there. So let's take a look at the facing. So we have use optimizations is enabled, and we have the feed rate reduction percentage set to 25%. Let's take a look at what we have for feed rate. So we have the cut feed rate at 10. So in the corners, it should drop to 2.5. So this is 10 inches per minute. At the corners, it should drop to 2.5 inches per minute. Let's take a look at, it should be 1/8 prior and 1/8 of an inch after each corner. Okay, so let's generate that again. Let's post that. So here you'll see that we have a feed rate of 10. Okay, and at every corner it's dropping to 2.5. So all throughout the whole part, you'll see it drop to 2.5 at each corner. At the beginning, it'll drop, and then after it turns the corner, it will speed up to 100%. So that's feed rate optimization in action in 2-axis facing. Let's go ahead and minimize that. Let's take a look at the profiling. Okay, so your feed rate optimization is not going to, well, we do have it in there. You can apply it to profiling as well. Okay, so that is 3-axis feed rate optimization. Let's take a look at our next 3-axis part, which is, let's take a look at this one here.